Drop what you're doing. Seriously. Right now, over 70 million targets are directly in the crosshairs. Welcome to The Explainer. Today we are looking at an absolute infrastructure emergency. We're breaking down a fatal authentication bypass, CVE 2016/419040.
If you're a system administrator, you need to listen up, because the stakes literally do not get any higher than this. What does this vulnerability actually mean for your infrastructure? It means an attacker gets an unauthenticated root shell on WHM in just 3 HTTP requests. Yeah, you heard that right. 3 simple requests to completely own the server.
Okay, so just how bad is this? Well, it's got a CVSS 9.8 critical severity score. And why is it a 9.8? Because there's 0 user interaction required, 0 valid credentials needed, and honestly, the scariest part? Active, in-the-wild exploitation is happening as we speak. This isn't just some theoretical white paper bug. Servers are actively being compromised right now over the network.
To really grasp the catastrophic blast radius here, we've got to talk about the two-plane model of cPanel and WHM. Think of it like this. You've got the WHM root plane at the very top, that's the master key to the kingdom, and the cPanel user plane sitting right beneath it. Compromising that root plane, that raises the stakes to an absolute system-wide failure.
Let's explicitly contrast these two. Down on the user plane, cPanel is just managing individual hosting accounts and isolated websites. But WHM, the root plane, that controls server-wide configurations, kernel updates, account provisioning, the whole shebang. So, the crucial point is this. Compromising WHM grants root equivalent access to thousands of cPanel accounts, databases, and emails beneath it. If an attacker owns the WHM plane, they own absolutely every single tenant on that machine.
Now, what makes this exploit so fascinating and terrifying is that it's not just one massive coding error. It's actually 3 independent micro-level flaws that chain together perfectly. None of these flaws are necessarily fatal on their own, right? But sequentially, they completely dismantle the system's defense in depth architecture. Let's break down exactly how this exploit chain works step by step.
Step 1. Silencing the encoder. Normally, when a pre-auth session is minted, it uses an encryption key. But because of how the Perl programming language evaluates truthiness, an empty string or an undefined value is basically treated as false. So by simply dropping a single comma in the tracking cookie, the attacker forces that encryption key to evaluate as falsy. The server then silently disables its own encryption, meaning it writes raw plaintext directly to the disk. Okay, moving to step 2. This is where the actual poison gets injected. The attacker sends a basic auth request, but they take advantage of a critical CRLF blind spot. This lets them inject carriage returns and new lines. And because the encoder was disabled back in step 1, the attacker can forge top-level keys. They're literally writing hasroot = 1 directly into the raw session file.
But wait, doesn't the system have a defense against this? Well, step 3 is all about bypassing the JSON cache defense. Normally, the authentication system safely reads from a JSON-encoded cache. However, the attacker intentionally omits a parameter called the CP_security_token. This forces a system error, triggering a fallback path that completely bypasses the safe load logic. Instead, it reads that poisoned raw file from step 2 and permanently overrides the safe JSON cache with those malicious keys.
And here's the final fatal step, the skeleton key. Because the attacker injected a flag called successful_internal auth with timestamp and set it to 1, the Perl code sees this as a truthy value. At gate 1, this specific injected flag completely bypasses the normal password checking function. The system just returns auth OK. The attacker walks right through the front door.
Let's summarize this whole 4-step chain. 1. Mint a session. 2. Poison the raw file by skipping the encoder and injecting keys via that CRLF blind spot. 3. Force an error to promote that poison to the cache. And 4. Authenticate as root. The attacker is literally forging the server's own internal session state by chaining together these requests. Honestly, it's a masterpiece of exploitation.
Zooming back out for a second to the macro level, this is exactly why we're hammering home that this is an absolute emergency. It lands on a catastrophic 9.8 CVS score. I mean, this is literally as bad as it gets for infrastructure management.
Just think about this quote for a second. No valid credentials, no brute force required. 3 HTTP requests. Deterministic execution. That should send chills down the spine of any defender. Picture an attacker just running a simple script, there's no password required, and it executes perfectly on a deterministic timeline every single time.
So, we know the problem is massive. Now we've got to pivot to the solution. If you're managing cPanel and WHM servers, you are now entering the mandatory emergency remediation phase. You absolutely must execute these exact steps to protect your environment. Let's look at the emergency remediation matrix.
Here is your strict checklist. Step 1. Force patch your system to version 11.11.0.97 or higher right now. Step 2. Hard restart the cpsrv daemon. Step 3. Aggressively purge all raw and cache session files from the disk. You've got to eliminate any pre-planted poison sessions. And Step 4. Audit your access logs for indicators of compromise.
I really need to fiercely emphasize Step 2 here. The difference between a soft restart and a hard restart is absolutely critical. A soft restart, like a sci-hub, is entirely insufficient because those vulnerable Perl modules, they stay cached in active memory. You must issue a hard restart. As the mandate demands, hard restart. Do not skip. Send a sig kill to ensure the patched module is actually loaded fresh from the disk.
Okay, once you've patched, we shift into hunting mode. You need to check your system for forensic indicators of compromise. And let me be perfectly clear for the defenders out there. Any hit on these specific session files or logs equals active or attempted exploitation on your server. No exceptions.
Feel free to pause the explainer right here so you can copy this text. These are the exact grep commands you're going to need. For host-based IOCs, search your session directories for successful_internal auth or has root equals 1. For log-based hunting, you're looking for a highly specific 3-request fingerprint originating from a single IP in rapid succession, a post to login, a post to JSON API with the CRLF payload, and a get to JSON API that's missing the security token.
Now, if you run those commands and actually find those indicators, I have to deliver a pretty grim warning. Root access means your underlying operating system is entirely untrusted. If you find malicious SSH keys added or web shells deployed across your hosted domains, patching in place just isn't going to cut it. You are mandated to perform a full migration of all hosted accounts to a clean, newly provisioned server or execute a complete bare metal OS reinstall.
Before we wrap up, there's a broader architectural lesson here, and honestly, this is the ultimate takeaway for DevOps engineers designing these systems. The strategic pillars for secure app design show us that the fundamental flaw was trusting client-controlled state, like a mutable session file on a disk, to dictate authentication outcomes. You can never, ever trust attacker-visible data to act as a definitive server-side authority.
Which brings us to our final uncompromising call to action. Sanitize at the write point, validate at the read point. Yes, the vendor patch fixes the write sync, but the architectural lesson remains absolutely critical. Sysadmins, your infrastructure is in the crosshairs. Patch immediately, enforce that hard restart, and hunt for those IOCs right now. But it does leave us with a lingering question. We patched the specific write sync today, but how many of your other critical systems are blindly trusting client-side state right now?